Scientists at NASA are now closer than ever to answering one of humanity's oldest questions. Are we alone in the universe? In a historic breakthrough, the James Webb Space Telescope has reportedly delivered the clearest and most detailed observation ever made of Proxima Centauri b, often called Proxima B, a rocky exoplanet orbiting the nearest star to our Sun. For decades, exoplanets existed mostly as indirect discoveries. Scientists could detect their presence by measuring tiny movements in stars or slight dimming of starlight as planets passed in front of them. But actually seeing these distant worlds in meaningful detail remained one of astronomy's greatest challenges. Now, that may be changing. When the Webb telescope's new data was revealed, astronomers were astonished. Instead of a faint invisible object hidden beside a bright star, Proxima B appeared as a tangible world with visible atmospheric and surface characteristics. Using Webb's advanced instruments, NIRCam MIRI coronagraphic imaging systems, scientists managed to suppress the overwhelming glare of its parent star, Proxima Centauri. This allowed researchers to isolate faint reflected planetary light with unprecedented precision. The result was extraordinary. The data suggested variations in surface brightness, possible atmospheric layers, and even hints of polar ice regions. While the images are nowhere near as detailed as photographs of Earth or Mars, they represent a massive leap forward in humanity's ability to observe alien worlds. For the first time, exoplanets no longer feel like abstract ideas. They feel real. The significance of this breakthrough extends far beyond a single image. For years, scientists could estimate only a few basic properties of exoplanets: mass, orbit, approximate size, distance from their stars, but understanding an exoplanet's atmosphere, climate, or surface conditions remained nearly impossible. The James Webb Space Telescope is changing that. Its infrared sensitivity allows astronomers to analyze planetary atmospheres by studying how starlight interacts with gases surrounding distant worlds. Proxima B is especially important because it orbits within the so-called habitable zone of its star, the region where temperatures could theoretically allow liquid water to exist. The planet is approximately 1.3 times m², meaning about 1.3 times the mass of Earth, making it a rocky terrestrial planet rather than a gas giant. Located roughly 4.24 light-years away from Earth, Proxima B is our closest known potentially habitable exoplanet. That proximity has made it one of the most fascinating targets in modern astronomy. Previous telescopes struggled to observe it because its host star is both dim and highly active, frequently producing stellar flares that interfere with measurements. But Webb's powerful optics and filtering systems overcame many of those challenges. The spectral data revealed possible atmospheric signatures including carbon dioxide, water vapor, methane traces. While none of these chemicals confirm life, they are associated with environments that may not be hostile to biology. Temperature estimates derived from infrared emissions also suggest moderate conditions that could potentially support liquid water under the right circumstances. Scientists were particularly fascinated by Proxima B's appearance. The planet seems to display contrasting bright and dark regions that may correspond to ice-covered areas, rocky deserts, oceans, dense cloud systems. Its faint reddish hue, likely caused by illumination from its red dwarf star, gives the planet an alien yet strangely familiar appearance. For astronomers, this achievement marks a turning point. The search for exoplanets is no longer just about discovering worlds. It is now about studying them directly. The discovery surrounding Proxima Centauri b has sparked enormous excitement because of what it may imply about life elsewhere in the galaxy. For centuries, humanity wondered whether Earth is unique. Now, thanks to the James Webb Space Telescope, scientists are beginning to study alien planets in ways once considered impossible. The atmospheric signals detected around Proxima B may suggest conditions capable of supporting life as we understand it. Researchers emphasize that no evidence of life has been found. However, the possible presence of water vapor, carbon dioxide, methane, moderate temperatures makes the planet especially intriguing. On Earth, life has proven remarkably adaptable. Microorganisms survive in frozen tundras, acidic lakes, deep-sea hydrothermal vents, high radiation environments. This resilience suggests that life elsewhere may also survive under conditions once thought impossible. If planets like Proxima B truly possess stable atmospheres and Earth-like environments, then the ingredients for life may be common throughout the galaxy. The implications become even larger because Proxima B orbits a red dwarf star. Red dwarfs are the most common type of star in the Milky Way galaxy, making up roughly 70% of all stars. If rocky planets around red dwarfs can support stable climates, then potentially habitable worlds may exist in enormous numbers across the galaxy. This discovery also opens the door to studying many other nearby planetary systems, including TRAPPIST-1 LHS 1140b. Astronomers are already developing advanced climate models for Proxima B to estimate atmospheric circulation, surface weather, ocean possibilities, rotation patterns, magnetic field strength. A magnetic field would be especially important because it could shield the planet from harmful radiation emitted by its active parent star. One of the most remarkable aspects of this achievement is the collaboration behind it. The Webb observations required expertise from astrophysicists, engineers, chemists, planetary scientists, computer scientists, artificial intelligence specialists. Advanced machine learning systems help reconstruct faint planetary light from noisy observational data, improving image clarity and atmospheric analysis. This breakthrough demonstrates how modern astronomy depends on multiple scientific disciplines working together. The emotional impact of the discovery is also profound. Seeing even a partial image of another Earth-like world changes how people think about the universe. For the public, Proxima B is no longer just a scientific concept hidden inside research papers. It has become a visible place, a world orbiting another sun. Schools, museums, planetariums, and science communities around the world are already using the imagery to inspire future generations of scientists and explorers. From a technical standpoint, the observation was incredibly difficult. The telescope had to maintain extreme thermal stability, perfect mirror alignment, precise pointing accuracy while compensating for Proxima B's orbital movement, interference from stellar flares, faint reflected planetary light. The observation process reportedly required weeks of repeated measurements to ensure the data was accurate. Yet scientists believe this is only the beginning. The success of Webb has renewed interest in future interstellar exploration projects such as Breakthrough Starshot, which aims to develop tiny laser-propelled spacecraft capable of traveling to nearby stars. Knowing more about Proxima B's atmosphere, temperature, and surface conditions could help guide the design of future probes and instruments. For decades, visiting another star system existed only in science fiction. Now, it is becoming a scientific objective. And perhaps most importantly, this discovery changes humanity's perspective. The universe suddenly feels less distant, less empty, and far more alive with possibility.